Dear friends, welcome you at Meera Online Learning Center. We are studying Newton's law of motion for past 2-3 days. We have already covered all the three laws of motion given by the famous scientist physicist Newton, and also we have seen the nature of force applied on any object at different times and space. Now we are moving to apply those laws of motion to solve some problems for better understanding of these laws. Here we are seeing that a particle of mass 50 gram moves in a straight line. The variation of a speed with time is shown in figure. Find the force acting on the force. What we want to know? We want to know the force acting on the particle at time t is equal to 2 seconds, t is equal to 4 seconds, and t is equal to 5 seconds. What will be force 1, force 2, force 3? We are seeing here that the particle is moving with constant acceleration for time 0 to 3 seconds. Because here speed is continuously increasing from 0 to 15 meter per second with uniform acceleration. Then for time 3 second to 5 second, there is no change in a speed. So acceleration for this area becomes 0 and a speed remain constant. So object is moving with uniform velocity or say speed. After 5 seconds to till 8 seconds, the speed is continuously decreasing, and here the acceleration, this is decelerating. So this gives the negative acceleration. So let us find out what is the acceleration for time 0 to 3 seconds. So we are say as speed as acceleration is constant, we can say that average acceleration is equal to acceleration for the path from 0 to 3 seconds. Acceleration is becomes final velocity minus initial velocity upon time taken. This formula is applicable for this range 0 to 3 seconds. Otherwise, we have to write a average. So this will give 15 meter per second minus 0 upon 3, that is 5 meter per second square. Now, what is the mass of the object? Mass is 0.05 kilogram. Now see this first condition, T1 is equal to 2 seconds. So at T1 is equal to 2 seconds, acceleration is just 5 meter per second square. So according to second law of motion, force is equal to mass into acceleration. Because this is a linear motion, we can simply write this F is equal to ma, because plus or minus will give the direction of this force F. Okay, so here mass is 0.05 kilogram multiplied by this 5 meter per second square. This will give 2.25 Newton. This is our F1. Now, what is our acceleration during this 3 second to 5 second? 3 second to 5 second. There is V is constant for this time period. So acceleration will be 0. So according to second law of motion, this F is equal to ma, that is 0. So here F2 is equal to 0. So no force is applying during 3 second to 5 second. Now we have to find out what is F2. F2 means T is equal to 4 seconds. Now Let us consider for the time. This is 5 second to t 5 second to 8 second. Here velocity is continuously decreasing. Again we can apply this average formula of acceleration for this range. The final velocity is 0, initial velocity is 15 meter, and again it is taking how much time? This is taking 3 second. 8 minus 5 second, 3 second. So this will become 3. This is giving 5 meter per second square. Negative showing if the speed is coming down. So force for this period will be F3 at t is equal to 5 second MA, that is minus 0.25 Newton. So what is the meaning of this negative or positive forces? In this case, we are pushing the object in the direction of velocity, so velocity keeps increasing. But in this range, we are pushing the object in the opposite direction of the velocity, so velocity starts decelerating. Now let us see the second question. A particle of mass 0.3 kilogram is subject to a force F is equal to minus kx. F is equal to minus kx, where k is equal to 15 Newton per meter. What will be its initial acceleration? Initial acceleration means, what do you mean by this initial? Initial means at t is equal to what will be acceleration. If it is released from a point x is equal to 20 centimeter. So at t is equal to 0, x is equal to 20 centimeter, then what will be the acceleration? That is our requirement. So we can draw the diagram of this force versus, like this is our x and this is force. So what will be the direction of, see, if we are taking f positive and if x is increasing, in that condition this f will be in the negative zone. If x is negative, then this f will be positive. Okay, this is negative, this is positive. Now we have to just consider at the initial position, that is that t is equal to 0, x is 20 centimeter, I mean 0.2 meter. So force will be 20 centimeter into, sorry, force will be minus kx. What is the value of minus k? 15 Newton per meter. And what is this x? 0.2 meter. So this will give 3 Newton. See, x is positive, so force is coming negative. X will be negative, force will become positive. Positive means if in this position velocity will increase, in this position velocity will decrease. So now we just need to know about what is the acceleration. So we have to use again the second law of motion, that is F is equal to ma. So here F is, so acceleration will be F minus m. What is F? Minus 3 Newton upon what is m? M is 0.03 kilogram. 0.3 kilogram. So this will be minus 10 meter per second square. So in this range, it is decelerating. Now let us see the third problem. So we have a block of 2 kilogram, a block of 2 kilogram suspended from a ceiling, by a massless spring. Massless spring means tension will be constant throughout the spring. Of a spring constant K is equal to 100 Newton per meter. What is the elongation of the spring? See the situation. A block is suspended from ceiling by a massless spring. So let us consider a situation if no mass is suspended with this spring. So this will have some natural length L. When you are suspending some object which has some mass m, so this will elongate by some x, by some x. So this will be the elongation because of this mass m. Okay. So what is the elongation? What is the problem? What is the elongation? So we have to find out the x. What is x? If another 1 kilogram is added to the, let us first see this first part of the problem. So according to a spring, we know what is the spring force. The spring force is minus kx. K is a spring constant and x is elongation. So this is our spring force. Here elongation is x and force is minus kx. That means a spring is trying to pull this object towards ceiling. So let us first draw the first free body diagram for this mass m. Whole system in rest position. So on all the subject, on all the object, gravitational force is always applied. The first force will be gravitational force, that is mg, and a spring force will apply upward. So this will be F is equal to minus kx. Here we have to consider the magnitude. In upward direction, we have to take this positive. Okay. So what will be this? For drawing this FBD, we have to take a point for this object, and from that point, this will be mg, so that the line of action of the forces will be same, F due to a spring. So now what will be the equation of motion? Equation of motion. Let us consider that acceleration is downward. Let us say this acceleration A is equal to 0. So according to second law of motion, ma is equal to sum of all the external forces applied on the object. So here this mg is downward and minus kx will be the spring force. Now acceleration is 0, so we have to take this as 0. Now mg is equal to kx. So what will be the elongation? Elongation will be mg by k. M is 2 kilogram. M is 2 kilogram, 2 into 10 Newton upon K will be 100 Newton per meter. 100 Newton per meter. That's mean this will be 0.2 meter. So what will be the elongation? Elongation will be 0.2 meter. Now let us move. If another 1 kilogram is added to the block, what would be the further elongation? So we are just adding in 1 kilogram. So the whole system will come down and there will be further some elongation. Let us consider that as y. Y. So in that situation, The mass is now 2 plus 1, 3 kilogram. So the force will be m1 plus m2 into g, and this will be kx plus y. Okay. Again acceleration is 0. So we will draw this FPT according to this m1 plus m2 g. So this is spring force acting upward. So m1 plus m2 a is equal to total external forces m2m minus fs. So this is 0. m1 plus m2 is 3 into 10 Newton, or minus 15 x plus y. So this x plus y will be 30 upon 15, and that is 2. Sorry, this is 100 Newton, 100. This is 100. This is 100. This is 100. This will be point 3. So this y will be 0.3 meter minus x 0.2 meter. That is 0.1 meter. Now two blocks of equal mass are tied to each other. Two blocks of equal mass are tied to each other through a light string. Light string. What do you mean by light string? Mass can be negligible. In that condition, the tension inside in the whole string will be T equal. One of the block is pulled along the line joining with a constant force F. So this is pulled by force F. Find the tension in the string joining the blocks. So let us draw the free body diagram of both the objects separately. For this, we have just one external force T, and we can also consider that it is kept on some surface, so that the weight is taken care of by normal force. So what will be the FBD in this point? We have to take tension in this direction, and mg vertically downward and normal force upward. So equation of motion will be in vertical direction, MAV is equal to mg minus n, that is 0, and in horizontal direction MAH barabar T. So let us consider this as equation 1. Now consider another body. This is second body with having the same mass. So again this will be mg n. This has external force F and tension T. So now we will have take as a point F T mg n. In vertical direction, again this will be mb is equal to mg minus n is equal to 0. In horizontal direction, this will be mah. Both will have the same acceleration because the string is tense. So mah is equal to f minus t. Let us consider as equation 2. So from equation 1 and 2, let us eliminate this t. So adding both, we will get 2mah is equal to f, and that means ah is equal to f by 2m. Now we have to find out what is tension. So from equation 1, T is equal to mAh. That means m into f by 2m is equal to f by 2. So tension in the string will be T is equal to f by 2. अब सभी लोगों ने देखा कि किस तरह से प्रॉब्लम हम कंसेप्ट का उपयोग करके कर सकते हैं। आप जो भी एक किताब है उसको फॉलो करिए और उसमें जो भी सवाल दिया गया है उसको इन्हीं नियमों को अप्लाई करके बनाने का प्रयास करिए, और कहीं भी कोई दिक्कत होती है तो हम लोग नेक्स्ट क्लास में आप उसकी चर्चा करिए। अभी के लिए इतना है।